This video will cover the first page of notes for the topic of graphing polynomials. Please note the 6 steps to graphing polynomial functions. First, we will find and graph the y-intercept. Remember, this is when we let x is equal to 0 and solve for the y value, or p of 0. It will be the point 0, some number. Second, we will need to find zeros of the polynomial and graph the x-intercepts. We can do this if we factor the polynomial completely and write it in an x-intercept form to quickly find the x-intercept values. Third, we can use the remainder theorem for additional points for the graph. We will not be using this step as you will not be asked to hunt for possible zeros. You will be given some zeros that you will use to factor the polynomial completely. 4. Use the knowledge in behavior. 5. Use the knowledge of multiplicity of zeros and factors. We will discuss this in the next page of lecture notes. 6. Create a smooth and continuous curve. Let's start with example 1. We need to graph p of x, which equals to x cubed plus 3x squared minus 4x minus 12. Step 1 is to find the y-intercept. We're going to plug in 0 for x and find p of 0 is equal to negative 12. The y-intercept is the point 0, negative 12. Step 2 is to find zeros. Remember, to find zeros we need to factor p of x completely. In other words, we want to rewrite p of x in factored form with 3 sets of parentheses and then set each set of parentheses equal to 0 to solve for the x values. Since p of x has 4 terms, we can try factoring by grouping, or we can just guess numbers that may be zeros of the polynomial and use synthetic division to verify that the remainder is 0. But what should we guess? From our experience of factoring, we should look at the constant for its factors and try those numbers. The factors of 12 are 1, 2, 3, 4, 6, and 12. We can also guess the negative of these numbers, which would be negative 1, negative 2, negative 3, negative 4, negative 6, and negative 12. Let's try to see if 3 is a 0 by dividing our polynomial by x minus 3. We will use synthetic division and the remainder theorem. After doing the synthetic division, we found that there is a remainder of 30. By the remainder theorem, we know that p of 3 is equal to 30, and the point 3, 30 is on our graph. But this point is not an x-intercept. Since p of 3 does not equal to 0, we can conclude that x minus 3 is not a factor. Let's try negative 3. And again, we will use synthetic division to divide p of x by x plus 3. Using synthetic division to find that there is no remainder, which means that we have found the value of p of negative 3 to equal to 0. Or we have the point negative 3, 0, which is an x-intercept. From the factor theorem, we can conclude that x plus 3 is a factor of p of x. This means we can rewrite p of x in factored form, so we have x plus 3 times x squared minus 4. And from our experiences of factoring, we can now factor the quadratic expression of x squared minus 4 into linear factors. This means we can rewrite p of x as x plus 3 times x minus 2 times x plus 2. Since we are finding zeros, we can find them to be the set of -3, 2, and -2, which means that we have x-intercepts of the point -3, 0, 2, 0, and -2, 0 for our graph. Step 4 says we need to see about the end behaviors of p of x. Since p of x is a cubic function with a positive leading coefficient, we know that the end behaviors will be similar to that of the parent cubic function. The left end of the graph will be going down to -infinity, while the right end of the graph will go up to +infinity. I will skip step 5 for now, since we will discuss multiplicity of zeros in the next lecture video. Step 6 is to create a smooth and continuous curve. So let's first start by graphing the points we have found. Since we are only going for the general shape of the graph, I will sketch the graph without our standard grid. Notice that I do have a scale for the x-axis, since we do have x-intercepts to plot, while the y-axis does not have a scale. Plotting the points of the y-intercept and the 3 x-intercepts, I will then go to the far left and create part of the graph using the end behaviors. I will draw the left end of the graph going down to -infinity, and then I will go towards the right and I will draw the right end of the graph going up to +infinity. Notice that the point 3, 30 is in the arrow on the far right of the graph. Because our zeros have a multiplicity of 1, and I also know the general shape of the cubic functions, I know that the graph will go through the x-intercepts. Starting from the left of the graph, I will have it coming from the -infinity through the x-intercept of -3, 0. Then it needs to come back down to go through the next intercept. It will go through the x-intercept of -2, 0 and continue down and around to the y-intercept and go back up to the x-intercept of 2, 0. And it goes through it and continues up to the +infinity. Notice that the curve is smooth, not pointy, and continuous with no breaks. This concludes this video.